Good morning, everybody. I am Professor Swamreddy from SR University, Department of Mathematics. In lecture 2, we discussed about the Laplace transform using first shifting theorem and Laplace transform of change of scale property and derivatives and second shifting theorem. In this lecture 3, we are going to discuss the Laplace transform of integrals, multiplication by t and division by t. Right? So first, the Laplace transform of integrals. What is the formula for the Laplace transform of integrals? If the Laplace transform of f of t is f bar of s, which everybody knows, right? Then the Laplace transform of integrals, integral 0 to infinite f of u du is equal to 1 by s into f bar of s. This is the integral formula. Just calculate the Laplace transform f of t, that is called f bar of s, and divide with s. So this is the integral Laplace transform. Now let's go to the problem. Here find the Laplace transform of integral 0 to t. Here sorry 0 to t, this one not infinite, 0 to t, 0 to t sin a t and dt. First, find the Laplace transform of f of t. What is f of t here? Sin a t. The Laplace transform of f of t is sin a t. Then, the sin a t Laplace transform a by h square plus a square. Already we discussed in the lecture 1. Sin a t, cos a t, sin h a t, cos h. Some standard functions we discussed in lecture 1. Now apply Laplace transform of integral formula. Here Laplace transform integral 0 to t sin a t dt equal to f bar of s by s. What is f bar of s? Here f bar of s is a by s square plus a square, right? For integration 0 to t sin a t, just divide with s, 1 by s. That's all. This is the Laplace transform integral 0 to t sin a t dt. And next, find the Laplace transform of integral 0 to t e power minus t cos u du. Or you can write this one 0 to t e to the power of minus t cos t dt also. Just to replace u by t. Find the Laplace transform of this. So what is the Laplace transform? First you write f of t. What is f of t? Its integrand is f of t. E power minus t cos t. So how you find the exponential and here cos function? Apply first shifting theorem. By first shifting theorem, find the Laplace transform e power minus t cos t. What is the first shifting theorem? Here e power minus t. First find Laplace transform of cos t. Find Laplace transform of cos t. This is equal to s by s square plus 1 square. Here t quotient is 1. So s by s square plus 1. Now by first shifting theorem, the Laplace transform of e power minus t cos t is equal to, here in place of s, what is right? S is replaced by s plus 1, right? E power minus t, e power minus at, e power minus at, s is replaced by s plus a. Here a is equal to 1, s is replaced by s plus 1. Therefore then its Laplace transform this one, s plus 1 by s square plus 2s plus 2, right? In place of s, just to write down this one, s plus 1 by s plus 1 whole square plus 1 square. That's all. Now the integral 0 to t e power minus t cos u du is equal, just divide with s into f bar of s. Here f bar of s is this, right? And next is find the Laplace transform of a triple integration 3 times, integral 0 to 2, integral 0 to t, integral 0 to t. So 3 times repeat integral formula. So first, what is f of t here? F of t is cos at. Then f bar of s is, both sides apply Laplace transform, s by s square plus a square, s by s square plus a square. Now apply repeatedly 3 times. So one time you apply 1 by s, second time you apply s square, third time you apply s cube. Here what is that? 1 by s cube. 3 times repeatedly apply, then s into s square plus a square. Now s gets cancelled. So this is equal to 1 by s square into 1 by s square plus a square. This is the Laplace transform, this one, right? This is about the Laplace transform of integrals, right? Next, the Laplace transform multiplication by t, or multiplication by t, or t power n, whatever it is, n is equal to 0, 1, 2, 3, you can write, right? T power n or t power n into f of t. Then what is the formula? Here f of t is piecewise continuous. This is a condition of sufficient conditions for the existence of Laplace transform. What are the two conditions, sufficient conditions? One is piecewise or sectionally continuous. And number two is exponential order function. Here f of t is piecewise continuous and exponential order function. Then the Laplace transform f of t is f bar of s. Now the Laplace transform of t power n into f of t is equal to minus 1 whole to the power of n. N times differentiate f bar of s with respect to s power n, where n is positive integer. N time differentiate with respect to s. If n is equal to 1, 1 time differentiate, 2, 2 time differentiate. This is the formula for the Laplace transform of multiplication by t or t power n, whatever it is. And then let's go to the problem. Find the Laplace transform of t sin at. Here n is equal to 1. N is equal to 1. How many times we differentiate? 1 time differentiate. So minus 1, right? df bar s by ds. Here f of t, what is f of t? Sin at. And f bar of s is a by s square plus a square. Now differentiate minus 1 d by ds. Only one time differentiate. F bar of s, a by s square plus a square. Right. So how you differentiate this? Here the Laplace transform of t into sin at is equal to minus 1 d by ds of a by s square plus a square. This is equal to minus 1 whole power 1 only 1. D by ds of, here a is constant, a into send to numerator, denominator numerator s square plus a square whole power minus 1. Now differentiate minus 1, differentiate. So n into n minus 1 formula. So a into minus 1 s square plus a square n into n minus 1. So minus 1 is minus 2, and derivative of this s square plus a square is 2s. Right? Now simplify this. So minus into minus plus, right? Here 2as, this minus plus. So 2s into a. 2as and this negative power sent to denominator. S square plus a square whole square. This is the Laplace transform t sin at, 2as by s square, using multiplication with t formula, right? And next, t cos at also we can find. So what is the Laplace transform for your cos at? Here f of t is cos at, cos at. Then f bar of s is s by s square plus a square. Already we discussed in the lecture 1 the standard functions Laplace transform. Right? Now the Laplace transform of t into cos at, t into cos at is given by -1 d by ds of s by s square plus a square. Differentiate this. So this is u by v formula. What is u by v formula? Derivative of u by v is, what is that? U dash v minus uv dash by v square. Right? So what is u here? U is s. U is s and v is s square plus a square. U dash, s derivative with respect to s is 1. V s square plus a square minus u v dash. U is s. V dash, v is s square plus a square. So v dash is s square derivative is 2s, a square derivative is 0. So a square plus s square minus 2s square by v square. So s square minus a square by s square plus this u by v formula applied here. Similarly, we can calculate the Laplace transform of t square into sin at. 2 times differentiate here. T square into sin at. Right? You know the Laplace transform of t sin at is 2as by s square plus a square whole square. Right? T square, already you know t sin at. Now once again differentiate, then you would get t square. So that is the Laplace transform of t square sin at is equal to -1. Only one time differentiate. Already one time differentiated in the previous problem. So d by ds of 2as by s square plus a square whole square. So now differentiate same u by v method. This is u, and this is v. U derivative of u dash 2a, s is 1. V s square plus a square whole square. V is a square plus a square whole square. Minus u v dash. U is 2as. V dash is here minus 2, right? S square plus a square whole square, right? What do you say here? Minus 2 minus 1, right? And derivative of s square is 2s, right? Then b square s square plus a square whole square. Now simplify this, you would get this form, right? And next is similarly find the Laplace transform of t e to the power of 2t sine 3t. We have product of three functions t e power 2t sine 3t. First to find the Laplace transform of e power 2t and sine 3t. How you get e power 3t and sine 2t or sine 3t and e power 2t? By first shifting theorem. What is the Laplace transform for sine 3t? Sine 3t Laplace transform is 3 by s square plus 3 square. And Laplace transform of e to the power of 2t, only plus 2, e to the power of 2t sine 3t by first shifting theorem. By first shifting theorem, what do you replace here? S by s minus 2 because e to the power of 2t, right, a is equal to s minus 2. So therefore we get 3 by s minus 2 whole square plus 3 square is 9, and simplify this one. Now the Laplace transform of t into e to the power of 2t sine 3t is the multiplication with t formula, one time differentiate because t power 1. So d by ds of 3 by s square minus 4s plus 13. Differentiate is sent to numerator. right? This denominator sent to numerator. So minus 1 whole power n. So this is equal to minus minus plus 1, and here s square minus 4s plus 13 whole power n into n minus 1. So minus 2, and derivative of s square is 2s minus 4, right? And simplifying this, I send to once again numerator to denominator. So this is 6 into s minus 2 by s square minus 4s plus 13 whole square. This is the Laplace transform of multiplication with t formula. And next is Laplace transform of division by t. Division by t formula. So how you find the division by t? You know, multiplication with t and integrals. Next, division by t formula. If the Laplace transform of f of t is f bar of s, Laplace transform of f of t is f bar of s, right? Then the Laplace transform of f of t by t division by t is equal to integral s to infinite f bar of s ds. This is division by t formula, f bar of s ds, right? So now let's go to the problems. Find the Laplace transform of, what is the problem here? Find the Laplace transform of e to the power of minus at minus e to the power of minus bt by t. Here f of t by t. What is f of t here? F of t is e to the power of minus at minus e to the power of minus bt. Right? Find the Laplace transform first of all, this one, f of t. So the Laplace transform f of t is e power minus at 1 by s plus a, right? Minus e power minus bt 1 by s plus b. This is a f bar of s. Laplace transform f of t is f bar of s. This is f bar of s, right? Now apply division by t formula. Here f bar of s is this, division by t formula apply. So this is equal to f bar of integral s to infinite f bar of s. F bar of s is this. So this is equal to integral s to infinite f bar of s 1 by s plus a minus 1 by s plus b ds. Integrate. So this is equal to integration of 1 by x. So log x. So log s plus c minus log s plus b. Right? Now this is log m minus n. Log m minus log n. So log m minus log n in formula log m minus log n. So this is equal to log of m by n. So that is log of s plus a by s plus b. Here 0 to infinite, limits 0 to infinite. Sorry, not 0 to infinite, s to infinite. Our formula is s to infinite. S to infinite. Now let's substitute here. First upper limit. If you substitute upper limit, what happens? You would get infinite by infinite. S is equal to infinite. S is equal to infinite. Infinite indeterminate. So rearrange this. In the numerator, take out s. In the denominator also, take out s. So s gets cancelled out. So 1 by, this is 1 plus a by s, 1 plus b by s. Now apply limits. So 1 plus a by infinite. Something by infinite go to 0. Something by infinite go to 0. Then what we get? Log of a by infinite, b by infinite. Minus log of 1 plus a by s, b by s. Right? This is equal, not equal. Right? So this is log 1, lower limit now. S is equal to S. This is log 1 minus log of s plus a and s plus b. So this is equal to log of s plus b by s plus a. What is this? This is the Laplace transform of the given function applying division by t formula, right? So what is division by t formula? The Laplace transform of f of t by t, right, is equal to integral s to infinite f bar of s ds. What is f bar of s? F of t. And next, let's see this one also. Here, the Laplace transform of 1 minus cos at by t, right? This is also division by t. First, find f of t Laplace transform. F of t equal to 1 minus cos at. F bar of s is, what is the Laplace transform 1? 1 by s. And cos at Laplace transform s by s square plus a square. S by s square plus a square. Now apply division by t formula. Laplace transform 1 minus cos at by t. This is equal to integral s to infinite 1 by s minus s by s square plus a square ds. Right? So this is equal to, what you say, 1 by s integration is log s minus, this is multiply and divide with 2. Multiply and divide with 2. Then what we get? F dash of integral f dash of x by f of x formula applied dx. This is equal to, what you say, log f of x. Multiply and divide with 2. So this is 2s. Here 1 by 2 is there now. So s square derivative is 2s. F of x derivative is in the numerator f dash of x. So log of this formula is log of s square plus a square, right? So this is also log m minus log n, right? Here 1 by 2 take out here. So here you will get 2 here if you 1 by 2 take out. So this 2 goes to s power 2, s power 2. So s square by log m minus log n is s square by s square plus a square whole square. Now substitute limits. How you substitute limits? Then you see here. How you substitute limits? Same. Take out from the numerator and denominator s. So and s gets cancelled. S square take out. Right? Now substitute limits. So this is equal s something by, this is equal to infinite. S is equal to infinite. So something by infinity is 0. So 1 by 1 plus 0. So that is log 1 minus, let's take LCM, s square plus a square. How you get this function? What is our original function is log of s square by s square plus a square. We substitute infinite, infinite, indeterminate form. So that's why I'm taking s square common from the denominator 1 plus a square by s square. So s square gets cancelled. So this is what 1 by 1 plus a square by s square. Now this is log 1 minus log s square by s once again, right? Upper limit minus lower limit. Now this is equal to log 1 is, what is log 1? 0. So minus 1 by 2 log of s square plus a square whole square. So log of s square plus a square by s square to the power. For example, this is equal to log of s square by s square plus a square whole power minus 1 by 2. Just replace this log of s square plus a square by s square. This is plus 1 by 2. That's, this is about uh, problem division by t. And if you see one more problem also, this one. What is that problem? Find the Laplace transform of integral 0 to t sine t by t dt, right? Sine t by t dt. What is here? How you get the Laplace transform sine t by t dt? First division by t formula, and next Laplace transform integrals formula. Here two formulas involved in this. First division by t formula apply. Division by t is, you know, here division by t means first f of t is sine t. Then f bar of s is 1 by s square plus 1 square. Division by t, what is the division by t formula? That is the Laplace transform of f of t by t is equal to what we write? Integral s to infinite 1 by s square plus 1 square ds. This is the division by t. So Laplace transform sine t by t is equal to, right, s to infinite f bar of s ds. F bar of s ds. This is f bar of s. F bar of s ds. So 1 by, you know the formula, uh, integral, right? Integral 1 by x square plus a square dx is equal to 1 by a into tan inverse x by a. Here a is equal to 1. So that is tan inverse s. Now upper limit minus lower limit. Tan infinite is pi by 2 and tan inverse s is s. So this is pi by 2. Pi by 2 tan inverse s is cot inverse s. Now apply integral form. First division by t formula. Second integrals form. What is integral form? Integral 0 to t f of u du is equal 1 by s into f bar of s. What is f bar of s? Here f bar of s is cot inverse, yes, cot inverse yes. Right. Now the Laplace transform of integral 0 to t, right, sine t by t dt equal to f bar of s by s. So 1 by s into cot inverse s. Cot inverse s. This is the division by t. So we discussed what are the problems here? Division by t, multiplication with t, and integrals. These three formulas rigorously discussed. And, and next is for division by t is another example. Find Laplace transform of cos at minus cos bt by t. So here what is f of t? F of t is cos at minus cos bt. Then what is f bar of s? Here f bar of s is Laplace transform cos at s by s square plus a square. Already we discussed in the first lecture. And Laplace transform cos bt s by s square plus b square. Now division by t, the Laplace transform of division by t. What is the formula? Laplace transform of f of t by t is equal integral s to infinite f bar of s ds. So this is f bar of s, right, and ds. Here f bar of s is s by s square plus a square, s by s square plus b square ds. Now integrate. So how we get integration? First you know the formula. The integration of f dash x by f of x dx equal to log f of x, log f of x, right? Here f of x derivative is in the numerator, denominator f of x derivative is in the numerator f dash of x. So For that you multiply and divide with 2. 1 here division, 1 by 2 here multiplication both. So 2s by s square minus 2s by s square plus b square. Now this is f dash of x and this is f of x. So s square derivative is 2s. Here s square derivative ds. So that is 1 by 2, right? Log of s square plus a square minus log of s square plus b square s to infinite. Now log m minus log n. So log m by n, right? Log m by n. Now if you substitute direct limits, what happens? Goes to infinite, indefinite form. So take out s square, right? And cancel this s square, right? Now upper limit. So log of 1 plus a square by infinite, 1 plus b square by infinite, right? This is, so minus lower limit s square plus a square plus a square, so this is log 1 and this is log of this one, right? So your log 1 is 0, your minus 1 by 2 this one. So this is equal to, if you cancel negative power here, just reverse this fraction s square plus b square by a square. This is the Laplace transform of cos bt by t. Now, so what we discussed in this lecture is Laplace transform of integrals, this formula, Laplace transform of multiplication, and Laplace transform of division by s. On these three formulas, we discussed many examples. Thank you very much.